Okay, the purpose of this video is to define isotopes and calculate the average atomic mass of an element. There are a few things we need to know, our required knowledge. We have to know the location, mass, and charge of the subatomic particles. Subatomic particles are the smaller pieces of an atom, so the electrons, protons, and neutrons. Here they are. So we've got our protons and neutrons in our nucleus and our electrons on the outside. So we can go ahead and fill in this little chart. So protons are in the nucleus. Oops, let's do that. They're in the nucleus. They have a mass of 1 AMU and a charge of 1 plus. The neutrons are also in the nucleus, again with a mass of 1 AMU, that's atomic mass unit, and they are neutral. The electrons are in the electron cloud. They don't have mass, and they have a charge of 1 minus. Okay, so all of those pieces are going to factor in when we talk about what an isotope is. So we also have to know that protons define the element, meaning if something has 12 protons, that something is magnesium. It doesn't matter how many neutrons there are or how many electrons there are. The neutrons would make it heavier. More electrons could make it more negative and not neutral anymore. But still, if there's 12 protons, that thing is magnesium. The second you change the number of protons, it's no longer magnesium. We also have to know that the mass number is the number of protons plus neutrons for just one atom. So, for example, if you wanted to know the mass number of one magnesium atom, we know it has 12 protons. You'd have to know how many neutrons it had. Let's say it also had 12. So 12 plus 12 is 24. So that first atom of magnesium would have a mass number of 24. But a different atom of magnesium could have 12 protons again, has to, but maybe it has 13 neutrons. So 12 plus 13 gives us a mass number of 25. So atoms of the same element can have different mass numbers, which is why we have average atomic masses on the periodic table that are these weird decimals. So what they're looking at is they're looking at they are the average mass of all the atoms of one element in the world. So if you looked at all the magnesium atoms in the world and you took into account how much each one weighed and then got an average, you'd have the average atomic mass. So now, isotopes, a new word for us. So isotopes are atoms of the same element that have different masses. So here are 3 isotopes of hydrogen. So what must atoms of the same element have in common? What do they have to have in common? Well, if they're all the same element, they have to have the same number of protons. And we can see each of these 3 has 1 proton. Meanwhile, if they have different masses, what has to be different? Well, the only 2 things that have mass in an atom are protons and neutrons. The protons were the same, so the neutrons has to be different. And this first hydrogen has 0 neutrons. The second one has 1 neutron, and the third one has 2 neutrons. Okay. So let's figure out how to calculate the average. And what we're going to do is we're going to take a weighted average. And weighted averages look at how common and how big the values are that you're considering. So how common one isotope is and how much it weighs, and how common the second isotope is and how much it weighs. So we're going to do an example with grades because students do a pretty darn good job of figuring out what their grades are. Oops, let's move that back. So let's see. Imagine I gave a quiz where 75% of the class earned 100 points and 25% of the class earned 80 points. How could I figure out the class average? Well, if I just said the average between 100 and 80 is 90, that would be very bad because a lot more students got 100 than 80. So what I need an equation that looks at how common and how big each of the scores is. So here's our equation. The average is equal to the percent over 100 of the first value times the size of that first value plus the percent over 100 of the second value times the size of that second value. And this is what I mean. So if I want to know the average for this class on that one test, I say, well, 75% divided by 100. So 0.75 of them earned 100, and 25%, or 0.25, earned 80. And then I would just multiply these numbers out and add them together. 0.25 times 80 gives me 20, and 75 and 20 gives me 95. So 95 would be the average score for students on this test. So next, let's try that out with a chemistry problem. So copper exists as two different isotopes. There's copper 63, which has a mass of 62.93 AMUs, and copper 65, which has a mass of 64.93 AMUs. And 69% of all copper atoms in the world are copper 63. So I'm going to use the same equation. The average is equal to the percent that are the first isotope. So that's 69%. And I have to turn that into a decimal, so 0.69. And that was, they have a mass of 62.93 AMUs. Okay. And the percent that is the second isotope, well, that's 0.31%. And they had a mass of 64.93 AMUs. Oops, AMUs. Okay, so you go ahead and do the math for that, and you're going to get 43.42 AMUs plus 20.12 AMUs, and that adds up to 63.54, which isn't exactly what you see on the periodic table, but it's pretty close. The reason it's not exact is that I did round the percent. It's not a whole number. It's not an integer. And I rounded the masses too. The real masses don't stop at the hundreds place. There's like probably 10 digits that we know. But I wanted to start out pretty simple as we're learning this. So now it's your turn. Your problem is, of all the chlorine atoms in the world, they exist as chlorine 35 and 37. Chlorine 35 has a mass of 35 AMUs, and 75.77% of chlorine atoms in the world have that mass. The rest have a mass of 37 AMUs. What is the average atomic mass? Go ahead and pause. Okay, hopefully you paused, did some maths, and hopefully you got this. So, or something a little neater than this. So your average is equal to the percent that was the first isotope, so 75.77 divided by 100 times 35 AMUs, plus the rest of them were that chlorine 37, so 100 minus 75.77 would give you 24.23%, or 0.2423. So times that 37 AMUs. So then you go ahead and multiply these guys together to get 26.52. Multiply these guys together to get 8.965. And that adds up to 35.49. Again, it doesn't match the periodic table exactly, but we're rounding. Okay, so hopefully now you feel comfortable with calculating average atomic mass and knowing what an isotope is. See you in class.